From aerospace and automotive to healthcare and fashion, additive manufacturing is transforming industries and creating new opportunities for innovation and growth. We're proud to have this distinguished panel today. We look forward to have a lively discussion and with everyone over here. And we thank you for joining us for AMplify Malaysia, launching the Digital Forge. So without further ado, let's give a warm welcome to our esteemed panel and guests, and to introduce our CEO of ArmRace, Mr. Najib. Welcome, Mr. Najib.
Hi, good afternoon. Welcome to the Meranti Park Auditorium. This is the second session of the day, so thank you very much for coming this afternoon. This morning we had another group which were more manufacturing orientated, and some people that we didn't know. So this afternoon's more people that we are wanting to get to know and hopefully will join us in our journey. So I'm Najib, the CEO of the Advanced Manufacturing and Robotics Accelerator Center of Excellence, so mouthful, but you can call it ArmRace as abbreviation. And what we are is a center of excellence. So what we do is we bring organizations with different requirements, so from government, from industry, and from academia. And what we do is create synergies between these organizations so that we can create opportunities for example, companies to access new markets, government to support industry and academia, and then academia to understand what the industry requirements are. So I think this is our modus operandi. I hope that we will get some new members and new collaborators with us through this process. And we'd like to keep this session quite interactive. So today we have our technology partners. So led by Mark Forge, you'll hear from Richard in a second. So he'll give you an overview of the 3D printing technology and where it's going. But we also have some really technical sessions, I think, on design from PTC, ASTM talking about standards, 3D printing standards and other standards as well, and then some industry experience from Philips and Materialize, who are in the 3D printing space overseas and in Malaysia, right? So without further ado, I think I can go straight into the introduction of our next speaker. Yeah, okay, Cheng, let's save the time because Richard's got to pick up a plane. Thank you very much, Richard, from Mark Forge.
All right, first or second speaker after lunch. Let's see how we go. All right. So, what I'll be spending the next few minutes talking about is really where manufacturing is today, some of the challenges, some of the opportunities, and what we are doing at Mark Forged about it. So, as the previous speaker said, my name is Richard Elving. I'm the Senior Director for Mark Forged. I've been with the company now for about 5 years. When we started here in Asia Pacific 5 years ago, we had little to no revenue, we had no partners, and we had no presence. And today, 5 years later, we have over 30 staff working directly for Mark Forged and over 300 people employed via our value-added resellers. We've really begun the transformation and the reinvention of manufacturing. So why is this important? And why do we want to reinvent manufacturing? You know, what is it that's broken? What we have seen is that the world that we're living in post-pandemic is a very different world than the world that we saw before the pandemic. I don't know if you guys agree with me. A lot of things have changed, and if you are working for a manufacturer, you know that there's a lot of challenges that are presented today. Things like supply chain issues, things like waiting for parts, minimum order quantities, labor shortages, skills shortages. It feels like a lot of these things have been amplified since COVID. The other thing, right, is that companies have realized that leveraging technology is maybe not so bad. Maybe it's something that can really help us. If you think about what happened 3 years ago now when COVID struck, is that we were able to pivot and leverage digital technologies, and most companies were still able to kind of operate and communicate leveraging this type of new technologies. So these are some of the mega trends that are available to manufacturers today. Things like artificial intelligence, things like 3D printing. And these tools are essential for manufacturers to really thrive in this area of Industry 4.0. The 3D printing market is today an $18 billion industry and is expected to grow to $118 billion by 2030. So I think for you guys that are here in this room today, you're obviously interested to learn more about this, right? So if you're an engineer or you're a designer, then what's the first thing that you got to do? I think that it's really about changing our mindset when it comes to technology and when it comes to 3D printing. If you think about it, many designers, engineers that have a thinking using maybe a subtracted mind, right? And leveraging new technologies that you'll hear from Tim soon from PTC is really about leveraging design, 3D CAD design, to design for additive manufacturing so that you can leverage the technology and 3D printing and where it is today. So these are some of the companies in Southeast Asia that are today reinventing manufacturing, leveraging 3D printing. So I'm not sure if you recognize some of these logos, but just to mention a few, we have, of course, ST Engineering that everyone kind of knows, but we have an exciting subsea company in Singapore called Nodes Underwater System. So they're really leveraging Markforged's latest and greatest technology to produce prototypes and functional parts for subsea equipment, which is pretty fascinating, right? We have things like UAVs and drones being produced by rotors, and by leveraging Markforged, they're able to essentially reduce weights and customize components. So if you're a design engineer working for a company today, you might think, okay, why is innovation important? Why is 3D printing important? So here you can kind of see our timeline at Markforged and how we've been able to kind of reinvent and push ourselves. Like we could have easily, when the company was founded out of MIT in Boston back in 2013 and got funding from Siemens, Microsoft and Porsche, could have easily stopped in 2014-15 as the company that created the desktop carbon fiber machine. But it's all about pushing innovation forward, right? So that as a company, of course, you can cater and solve more problems, and as an engineer, all of these things that you can see here, and I mean there's lots of words, all of these obviously are hours and hours of engineering time and millions of dollars spent in R&D to develop new material, new software capabilities to essentially expand the market opportunities. So what that means is that this is where we are today at Markforged. We've developed what we call a digital forge platform. So what is a platform, and what are you as an engineer going to be leveraging this for? Well, essentially, imagine that you have a CAD file that you can import. Leveraging that to Markforged Digital Forge, it's been designed in such a way that the software will immediately tell you things like printing time. Depending on the material that you choose, it can actually also do assessments depending on strength. So these are all the software capabilities that will really help you as a design engineer to assess, could this part be additively manufactured quickly, faster, cheaper than the way that you're making it today. And then of course, we have developed all different materials in-house. So today we have 28 different materials that are certified. And these essentially have been designed so that it can give you the best strength to weight ratio. And also as a design engineer, you know that you can trust these types of material. And then the hardware. So of course we have a variety of printers ranging from prototyping to industrial parts to full-blown mass production of and full-blown metal binder jetting technology. So if you go back after this, then you can ask the owner of your business to say, hey, what if we could move some of our components from a physical inventory to a digital inventory? And I would say that as an engineer, maybe you start with 1% of the parts that you're designing today, right? And what could be the impact? But it's really about proving the concept and start leveraging additive manufacturing in your company, right? And this might help the managers in your company to think about how can you overcome supply chain challenges. So if you as an engineer have components that you couldn't get a hold of or that was taking a long time to import, then you can use this as a reason to justify the business case. Or you might see that there's engineering capabilities, components that can be made using additive manufacturing, but that were previously impossible to make using machining or casting or in molding. So this is an example of Stanley Black & Decker. This component used to be 8 pieces, and it used to be laser cut, welded, and then essentially some of the components also was cast and machined, and then it was assembled. So of course, skipping all of those steps and essentially metal 3D printing the component has saved Stanley Black & Decker not just time, but also money. So there's actually a cost saving per component. And this part can be made at any point and at any time. So if there's a spare part that is needed, wherever the customer is at, as long as there's a printer there, that part can be produced. So it's really about this kind of like distributed manufacturing. We had some discussions this morning around reducing emissions. So one of the questions was like, do you have some examples of how companies have reduced emissions, and how do we measure this? So I guess the answer this morning was really that there's lots of companies looking at this. I'd love to hear from you guys later if it's something that you guys as engineers have implemented. But more and more companies are looking at reducing emissions now, right, and embracing things like ESG. So if we can produce the parts locally without waste versus shipping the parts around the world, of course that's going to help massively. Before you walked in, you could see some of our printers that we have today. So you saw some of our 2 smallest printers. So you can obviously get a demonstration of those by the local team. I just wanted to point out there's 2 machines that we haven't brought here yet, but hopefully with your help, we'll bring them to KL very soon, right? One of them is the FX20. So we've got this as codenamed the Beast internally. This is a machine that can essentially produce over 0.5 meter precision components in continuous carbon fiber. What does that mean? Imagine being able to print full-blown drone unibodies, or being able to print aerospace components in things like Ultem, high temperature materials, and reinforcing them with carbon fiber. So this is really a game changer. And then lastly, we acquired a company last year which is called Digital Metal, and this is a full-blown metal binder jetting technology that can essentially be used to produce thousands of components each week. So 3D printing is no longer just about producing the 1, 5, 10 components a week. It can now produce thousands of parts. So if you have any type of metal components, and I'd say that's probably anywhere from the size of your finger to the size of your hand, and you're producing a lot of those, then this type of technology will probably be cheaper and faster. Thank you so much, guys, for listening.
Good afternoon, everyone. Thank you again, Richard, for the amazing presentation. So Richard has a flight to catch at 6 p.m. So he has to leave us now. So if you have any questions, feel free to post the questions to Richard now. Thank you.
I will say I've also got my team here. So I've got Stanley from Mark Forge, who's available. I think, did Edwin leave? Edwin should be floating around here as well. Then we have the team from Philips. So if you've got no questions now, then I'm confident that the team can help you guys. So cool. Thank you so much, guys. Thank you.
Thank you very much again, Richard. Next, we shall have Mr. Tim Yip from PPC to have his presentation.
King. A very good afternoon to all of you. My name is Tim. I'm the Regional Director from PTC. So for today, my topic, I'm going to talk about the renaissance of industrial product design. So today's event is about 3D printing or additive manufacturing. So before you can do additive manufacturing, I think maybe you need a tool to help you to create models so that you can print it. So that is what I do, or what I do in PTC, all right? So just now Richard talked about reinventing manufacturing, all right? So I think a lot of you would face the same thing. The world is changing. So this is a little short story about PTC very first customer. It's called John Deere. They are into the farming equipment. So basically they are the first customer of PTC that bought the CAD software from us, all right? So basically when they buy the CAD software from us, they actually buy it for product design. So over the last 30 years, we actually helped John Deere to move from product design to smart product to product system to system of system. So that is what PTC as a company we can do for our customer. And how we can help our customer to achieve that, basically we have a range of solutions to help them. So we have CAD to help them to do design, we have product lifecycle management solution to help them to manage the data, information, and all related standards, so on and so forth. We also have IoT to help them to collect data and how to use the data to advance the design or monitor their systems. And of course, we have AR to help them with learning and stuff like that. So this is what PTC has a company, the technology we have. So basically, the world is changing. Basically, me and Richard, we did not align our presentation, but you can see that both company, Markforged and PTC, this is actually the trend we saw. So a lot of our customers or manufacturers face things like, how do I drive innovation? How do I create a differentiated product? How do I manage the skill gap that maybe a lot of us face now? And how do I accelerate time to market, all right? So basically, PTC as a company, we look at our solution and continues to see what can we do to help our customer to make their life better, or maybe to some of our customers, how to help them to become cheaper, faster, better. So day in, day out, as a company, we look at the technology that we have, the offering we have, how do we make life easier for our customer? How do we help them to retain the knowledge? How do we make things easier for them? How do we maybe make things like lesser mouse click to get certain things done? So this is what we look at for the core CAD software, all right? But in addition, as a company, we also look at what are the emerging technology that may be impactful to our customers. So this is actually a Deloitte report. So we actually look at different industry analysts, and this is a Deloitte report that we think that these are maybe some of the emerging technology we should look at to see how we can help or value add to our customers. So based on this, we actually select what are the things that we think that can help our customer immediately now, and put the technology available for the customer. So some of the technology we identify will be areas like additive manufacturing. That will be the theme for today's presentation. We have things like advanced analytics, we have things like AI, we have things like simulation-driven design, Internet of Things, so on and so forth. All right. So basically, I think what we do, the market recognize that, they believe that what we did actually helped them. So that's why in the last 3 years, PTC or Creo is the fastest growing CAD tool compared to our competitors. So I think that's the good thing that we know that what we are doing is the right thing for what the market wants or what the customer wants. All right. So for today, the session is not so long. So I'll focus on a few topics. But basically at this point in time for emerging technology, we look at things like AR. How can we help our customer to use AR to help them to do collaboration? How can we use AR to help them to do learning and training? How do we use real-time simulation? So we actually partner with a company called ANSYS. How do you immediately know that whether the product you design, does it adhere to your design requirement? Or maybe a fat guy like me, I designed this chair, right? When I sell it, will the chair break? So basically, we introduce real-time simulation so that we make it easier for engineers to actually know whether the design is okay or not okay, all right? And of course, we look at things like AI generative design. So I think recently ChatGPT is a very hot topic, but we also have AI inbuilt in the CAD system. All right, so this can be a good area for you guys to look at how do we optimize the design, or how do we use AI with optimized design to reduce carbon emission, for example. All right, and of course we have this thing called IoT-driven design. So IoT is one of the strengths PTC have. Later I'll give you a quick illustration how do we use IoT-driven design. And last but not least, additive manufacturing, because we saw that there's actually a trend. Additive manufacturing is giving benefit to the customer, and there is also a lot of applications, and also now the technology is mature. We believe that this is the new wave of manufacturing. So these are the few areas we are focusing on for emerging. So maybe without further ado, I'll just go into IoT-driven design. So a lot of time when you do design, or when you have a product out to the market, different customers use it differently. So for example, in this case, one of the customer create this excavator. Different customers use it in different terrain, different condition. So how do I decide or make decision? What can I do to improve the next generation of design? So if there's some means that I can collect data from all these products, I would have some good, real justification why I should do certain things. Right, so for PTC, we actually have this platform called ThinkWorks, where you can collect data whether real time or offline, and you can use the data to facilitate your design decision. All right. So basically, to give you an example, this is a customer called Brick. They use this product insight extension, which is an add-on to the CAD system, and do analysis. How can they do improvement on your design? All right. So this is the product they have. It's a race car. And basically what the customer trying to do is, I want to find out if I do certain turn at certain speed, how do we impact the structure of the design, all right? So basically we put sensor onto the product, all right? And with the sensor, I can have instant or offline feedback to the CAD system and see how the condition impact the frame design, all right? So you can see whenever I turn at certain speed, it will record all the data, and I can use the data for my analysis or simulation. All right. So basically, what we're trying to do is, with the data collected, we are trying to replace design assumption with facts. All right. So that is what maybe a new trend that we're looking at that we think that will benefit customer, and this is within the CAD system itself. All right. So next, we talk about AI. Okay. So moving forward in the future, so for example, if I design this product, you may not even need to draw this thing yourself. You just give the condition to the computer will create the optimum design for you. So this is available actually now in terms of this technology. So in 2018, PTC acquired a company called Forstrom. So they have the leadership in this area, and we embedded this technology into our CAD software. So basically this technology allows us to autonomously create optimum design with AI. So I can actually set maybe the different condition, material, what is the manufacturing process, and the computer will actually generate the optimum design for me. I can also do a simulation. Okay, what happens if I use different type of material, different process that can give me a report. So this is actually a very good thing, because if you over-design a product, it incurs costs, your product becomes more costly. If you under-design, then maybe there's warranty issue and all that. So if you can have tools like that automatically and using AI to optimize your design, I think that would be very good for you. All right, so some of the benefit our customer have, like through this, basically you have a differentiated product, you reduce your design cycle by up to 20%, and more importantly, you optimize your material usage. So maybe today this material is more expensive. If I use another one, I put it in, this is okay, we can use that. Okay, and the good thing for PTC, after using this technology we embed, we are recognized by the industry as being the only CAD software that have leadership in this. So if this is an interesting topic for you guys, maybe you can reach out to me later on. I can do more in-depth session with you guys, all right? And I think more importantly is with this, what is the benefit? So this is an example of one of our customer companies that do engine. So, and basically, I think there's also a trend talking about sustainability, ESG. They use this tool as a tool to support their sustainability initiative. So after adopting generative design and also simulation-driven design, basically they are able to reduce parts usage by up to 15%. All right. And another company called Jacob Engineering, so basically they do all the NASA pack, or the pack for the NASA. So after using generative design, they shorten the design time by up to 20%. And more importantly, because they're in space, they need everything to be lightweight. They cannot have excess weight and all that. This solution helped them to lightweight their part and result in significant fuel saving. So just to give you an idea, so basically the design on the right basically is their own design. Design on the left is what they have created through generative. You can see that other than the weight reduction, they're also able to have the peak stress reduction by up to 73%. All right, so not only in terms of material saving, you also ensure that the design part perform optimally. All right, so this can be something to look at. Okay, and last but not least, the other trend that we are seeing would be additive manufacturing. So for PTC as a company, we saw that actually additive manufacturing has been around for more than 10 years. So now maybe it's about 10 plus years. The technology has become stable, and we see that there's good application, good trend in this technology. We want to take advantage of this. So in PTC, what we built into the system, we allow customers to have latest design, because with different latest design, it gives you different material property that can adhere to do what you want. All right. And of course, the first extension we have basically is for plastic, and the other extension we have actually is for metal. So the underlying technology we're using is actually materialized. All right. And basically has a closing for this. For Creo, other than all the emerging technology in additive space, basically generative, you can see that a lot of model is the output can be additive. Of course, you can choose the traditional, whether it's casting or CNC, that is also fine. And of course, we're also having leadership in terms of lattice design, and we're also a member of 3MF, which is a 3D printing consortium. So basically, if you want to look at an end-to-end solution, I think maybe you can also look at Creo with Markforged together as a total offering. So with that, maybe I will end my presentation. I hope this is useful for you guys, and thank you.
Thank you very much, Tim. Again, that is Tim Yip from PTC. Next, let us invite Dr. Alex Liu from ASTM Asia.
Good afternoon, everyone. So my name is Alex. I'm from ASTM International. I'm the head of Advanced Manufacturing Programs as well as the director for the Asia Pacific office. So very happy to be here with all of you this afternoon. And a quick introduction about myself. I graduated with a degree on mechatronics. Basically, I did a lot of hardware and software integration and a lot of programming. Figured that this is not something that I like. So eventually I went into mechanical engineering with additive manufacturing. And since 2007, I have been working with metal additive manufacturing, and predominantly I'm working on laser-based powder bed fusion technology. So this is Singapore, I'm sure all of you know. And my earliest days with connection with Malaysia back in 2019 was with Materialize as well as UPM. And more recently, this was just last year with Positive Yield, B3D. These are the service providers in Malaysia. So if you're looking to print parts, you can go to them. And October last year, I was with MITI and Meranti. And also MAMA is the Malaysia AM Association. So we are also associated with them. So a quick outline about today. I will share about ASTM International, followed by an overview on qualification and certification. So this is really a huge topic right now in the industry. People are looking at part qualification, people are looking at part certification. And then finally, what are the qualification approaches that can be adopted by utilizing standards? So about ASTM, We are a 125-year-old organization, established since 1898. We develop standards. We have about 146 committees that develop standards. As of now, we have developed about more than 13,000 standards. We also have MOU globally with different national standards body. For example, we have an MOU with a national standards body of Malaysia as well as Singapore. So under this MOU with them, they can adopt our standards to develop policies and to regulate the local industry. So our standards cover more than 90 over industry sectors, mainly on oil and gas, energy, as well as building and construction. These are our offices worldwide. We recently added our office in Singapore. We started in 2019, and because of pandemic, only yesterday we had our official opening of Singapore office. So there are different types of standards, test method standard, specification, for example, material specification, and practice and guideline standards. To get involved, if you're a student, you can join us as a member for free. Or if you are from the industry, you can join us as an organizational member. And as a member, you can get direct access to the latest volume of standard depending on which committee you subscribe to. So instead of buying one standard that costs say $40-50, you can just join the committee for say $75 and you get access to all the standards in that committee. F42 committee. So just now I mentioned we have 146 committees, and F42 is just one of them. F42 is the committee that develops standards specific to 3D printing. So we started in 2009 until now, 2023. 14 years later, we have about 40 approved and published standards and about close to 100 in development. So you can see that standards development is a lengthy process and it takes time. We have a special PSDO agreement with ISO. So under that agreement, standards developed by ISO, or rather standards developed by ASTM, can be offered to ISO for adoption. This is the overview of the subcommittee. So just now I mentioned there are different types of standards, right? So in this case, each subcommittee represents the different types of standards. So we have test method standards, design, and the ones in arrow are the new subcommittee that focus on applications and data. So these are the applications under the subcommittee for F4207. You can see that we are looking at aviation, space flight, medical, all the way to energy. So this committee is a special one. We meet twice a year, one in the US and one out of the US. And essentially, once you become a member, you can also participate in these committees together with us. You will see that in Asia, 2016 we were in Japan, 2018 we were in Singapore. This year we will be in Korea. Hopefully one day we can bring this committee meeting to Malaysia. Looking forward to that. This is the overview of the standards. Green are published standards and red are in development. So the purpose of sharing this is to show you that there are a lot of standard development activities in F4205, which is materials and processes. So you notice that actually there is a lot of demand as well as excitement around materials and process for 3D printing. And bulk of our activities are really driven by the industry, by the members. So these are actually the direct requests from the members to develop standards in specific areas. These two are examples that I wanted to share, design and materials and processes. And the last portion of the introduction on the Additive Manufacturing Center of Excellence. So we started this in 2018. There are 4 pillars: research and development. So we fund R&D projects that can lead to standards development activities at ASTM. The second pillar will be education workforce development. So we look at training. We look at upskilling, reskilling, and most recently, cross-skilling. How do we develop cross-skilling training content for people who want to work in, say, AM and data management? So this is one aspect of cross-skilling. There are many other examples like cybersecurity in 3D printing. There are also others like AI and machine learning in 3D printing. Third pillar will be standards and certification, which is the key of the topic today on certification. And lastly will be industry consortia. So we want to have, it actually serves as a consortium platform for all industry sectors to leverage AM technologies. And we also have Wallace Associates, a market intelligence company that we acquired about 2 years ago. So this acquisition is a strategic one. It has a lot of relevancy to ASTM because our bulk of our activities in fact are driven by market intelligence. So having this company under our umbrella is a strategic one and beneficial one. Now, we will now move into the key topic on qualification and certification. So in this space, you got to understand, certification is the highest level, followed by qualification. Then there is validation, then verification. So basically, everyone is gunning for certification. And in order to have a certification program, you need to have standards. So this is the bottleneck. ASTM is at the top. We develop standards. Testing certification body is at the middle. They adopt our standards to develop certification program to certify end users. So with this understanding, a lot of end users are requesting standards to be developed to us directly. And that's how we work with all the entire ecosystem. A basic question, what is qualification and certification? So, even different industries, different culture, different companies, in different economies, different countries, they have a slight variation and interpretation to qualification and certification. So, by consensus, qualification applies to parts and components. Qualification also applies to processes. However, certification can apply to design. So you have a certified design, for example. Subsystems and integrated systems. For example, the system is certified. So that's certification. And I'm going to read this just so that you understand. Certification is granted by the responsible reviewing authority. So the key here is again the authority. We are referring to authority of the local government. When the verification process is complete, assuring both design and as-built hardware can meet the established requirements to safely and reliably complete the intended mission. So this can be done by third-party certification. This will be done by regulatory certification by the authority. For this reason, we are working very closely with different authorities in different countries. Specifically, in Singapore at least, we are working very closely with the Building and Construction Authority. How can they adopt ASTM standards to develop building and construction policies and align to the International Building Code if they want to use 3D printing for buildings? Some fundamentals of certification, really we look at the building block approach. In the next few slides, we'll look at the different levels of this building block approach to address the variability, environment, stability, and other things such as design and process specific details. And some detail or sub-component tests may be used as well to validate the ability of calibrated analysis methods. So the last portion of the introduction would be the qualification approaches, which I mentioned earlier on, where we break down into the details in terms of the different parameters. The first would be the path to certification. It really depends on your end-use application. You want to qualify a process to a well-defined metrics. One example would be quality of the as-built parts, consistency throughout the built envelope. We always talk about 3D printing is able to print customized parts. But do you know that all these customized parts are printed together in a single built volume, built envelope? So there are differences in terms of the print parameters, and they are very sensitive. So for example, the laser can fluctuate between 375 watt to 425 watt if you set at 400 watt. And there are in-process monitoring. If your laser fluctuates beyond this, then this build will be considered scrap. And also in terms of the chamber temperature, so this is very interesting. In Singapore, in Malaysia, probably we do not have this kind of problem. When you print titanium and aluminum parts, you require argon gas to be filled into the chamber, okay, to prevent oxidation. So I was in Italy, and this setup that I saw, the argon gas is being pumped in from outside of the facility. It was during winter. They were telling me that during winter they print parts differently from summer. So we were wondering why. Only then I realized that during winter, as the argon gas passes through the pipes, it became really cold. And the moment it enters the chamber, it basically brings down the entire chamber's temperature. So to melt metal, say stainless steel for example, it has to go to 1000 degrees Celsius, right? So you can imagine 1000 degrees Celsius with very cold sub-zero temperature of argon gas. It actually induces a very rapid solidification, rapid cooling of the parts. So it has two things. One, the microstructure is totally different from normal cooling if it's not cold argon gas. Second, the part is susceptible to higher stress, so it tends to want to warp and deform under such a high cooling rate. So these are some of the things that we observe if the process is not stable. And finally, of course, the mechanical and physical properties. We also want to, as your microstructure changes, the mechanical performance of the part also changes. So this is something that we also want to have a look at it. On material qualification. So there are several stages involved in material qualification. First is the material specification. The buyer needs to specify what he needs in the material. So we look at the picture downstairs, it's actually basically powder, and it has different powder size distribution. So depending on the actual process and the requirements, you need to indicate your feedstock purchase specification as well as a use specification. Then comes the material testing and characterization. We have the inspection for quality assurance. What happens is that today in the aerospace industry, no questions asked. As long as the part printer is critical, they want to use brand new powders. They do not want to use recycled powders. They don't want to use reused powders. They don't care the quality of the recycled powders. They just want to use new powders for critical parts. That will drive up the cost. And economics 101, right? As your cost goes up, your demand goes down. So what happens is that with a proper material testing and characterization scheme in place, you are able to then qualify your recycled powders to that of the virgin powder quality. That will give added level assurance to the end user. Then there is material storage and handling. This is also important because when you store your material, I believe Malaysia is probably the same. In Singapore, humidity is 90%. The lowest probably I saw was 77% with the air condition. When it rains, it's 99%. So when we were printing, we realized that the powder at such a condition tend to stick together. They cannot flow. If they cannot flow, you cannot print well. And this doesn't happen in European countries at all because they're so dry, right? So then we improved our storage and handling. So what happens is that we have enclosed room. Basically, if you take photograph, right, you actually store your photography accessories in a dry box. But a dry box is so small. We are talking about a few tons of powder. You cannot buy such a big dry box. So we built an entire room, okay, 2 hours fire rated, make sure because it's flammable, and then we cannot even bring in those small dehumidifier, you got to bring the big ones. And we bring down the humidity down to say about 40%, 40-50%. Then at such a low humidity, electrostatic is an issue. And then you get sparks and things like that. And you have flammable powder, right? So then you got to ground the room and things like that. So these are some of the controlled environment that we need to take care of in terms of material qualification. Because if someone comes in to audit, they will audit your process, your storage, your handling, everything, all the way to the characterization of the powder. These are some examples of standards, test method standards that you can utilize to characterize your powder, such as flowability tests, such as tap density and things like that. Machine qualification. There is a need for machine qualification. We need to ensure that the critical requirements necessary for related product quality are satisfied. So I had the opportunity to set up several different centers, 3D printing centers in Singapore. The last one that I set up, we specified that the machine must be qualified in factory in titanium 64 ELI, grade 33. And when they ship over, everything must be in that powder, and we only dedicate that machine to grade 23 titanium powder. Why? Because we only want to specify it, we only use it for the aerospace and medical industry. Most OEMs will just use stainless steel powder to qualify the powder, the machine in their factory. Why? Because stainless steel powder is cheap. 1 kilogram is only $20. If you qualify using titanium, 1 kilogram is about $400 US. So usually they qualify the machine, do a simple one in the factory with stainless steel powder. So which is why we specifically specify that it has to be in titanium grade 23 powder, and also the steps in machine qualification. Good news, we have a standard for that, IQ, OQ, PQ standard. So under this document, the OEM can, depending on the end user, if they specify that the OEM needs to follow this document, then they have to follow our standard to have this IQ, OQ, PQ in terms of how the machine is going to be installed. That will facilitate machine qualification in future if they require to do that. Then we have process qualification. So basically this is mainly for operation control and production control to ensure consistent parts. We also have a standard that describes the steps in process qualification. We also have operator qualification. You know, in the aerospace industry, those welders, you need to be certified. So you have certified welders. In 3D printing, we don't do welding, right? We control the equipment to weld locally. So we call them the operator certification. So this has a standard on operator certification that is in fact complying to the aerospace requirement, because they need all the welders to be certified. So this was again a request from the industry, and we developed that standard. And then we have part qualification. Again, this is a classification for aerospace and defense. If you look at the classification A, B, C, D, A, consequence of failure is high. Meaning to say, if this part fails, okay, it can lead to direct death. If that happens, then it's high. So A, B, critical parts under that classification, they will need to use brand new powders. C and D, okay, we can use reused powders, because if the thing fails, there is no effect or very low. By the way, this classification standard is actually a derivation of NASA 6030 standards, where they utilize it and apply it to space components. And this is the part qualification approaches. Now, if you have a part that is certified, the design is certified already, okay? And now you have the function requirements changes, so you need to change the part design. The moment you change the part design by 5-10%, say you change the whole, right? The whole part has to go through the whole entire certification process again. So what happens is that this is a very new concept that we are in fact trying to encourage, which is the part family based approach, which means that we define part family. All parts under this family, okay, once they are certified, everything will be certified. You don't have to go through another round of certification process. And then the last one will be process based. This is heavily driven by NIST as well. They're looking at in-process monitoring, similar to what we do in all other manufacturing process. But the problem here is that the laser is scanning at so fast, You only see sparks, but actually it's scanning at, say, 400, 500 millimeters per second. So at that moment, at that moment, taking images is basically you get few terabytes of data from just 4 to 5 layers of printing. And to print one part, one layer is 30 micrometer. You print something this long, it's a few thousand layers. So you can imagine the huge amount of data that is taken out from taking images. And we're talking about high-speed imaging, because you need to know the process, the situation during the process. So as a result, this becomes difficult. So we are looking at ways to develop a guideline standard to capture images without to capture some images and not all images without compromising on the monitoring capacity. So we have also quality system leveraging on standards. This is just an entire workflow or value chain and the mapping of standards that are applicable to each stage of production. This is a very interesting one. And this is more marketing for myself or for ASTM. We have an additive manufacturer certification. This is a typo, not qualification. So we also certify service providers through our sister company called Safety Equipment Institute that we acquired many years ago. And we developed this certification program where they will come in to audit manufacturers. This is my last slide. International Conference for Advanced Manufacturing 2023. This is our annual flagship event. Last year we had about 850 participants, 530 plus presentations. This year we have crossed 730 presentations, and we're expecting to have about 1,000 attendees. So with that, I end my presentation and thank you for your attention.
Very much again, Dr. Alex. Now, let us welcome Mr. Lim Man Chun from Materialize to give his presentation for Materialize. Thank you.
Hey, good afternoon, everyone. My name is Manchun. So I'm the channel manager who look after the channel program in Materialize. And just a little bit of background of myself is that I'm graduated in mechanical engineering and started off my career as a project engineer. And I eventually found an opportunity about 3D printing back then in 2014. And ever since then, I see this as a future of the way of manufacturing. And after that, I'm since then in the industry for the past almost 9 years. So I'm still considering a baby in this industry itself, comparing to the veterans that's here in the hall, like Mr. Anuj or like Alex. They are in the industry for quite long. But yep, that's a little bit of introductions about myself. I'm currently in Materialize. And I guess in the hall itself is that most of us do have basic knowledge or know what 3D printing is, at least. 3D printing has been famous or well known in the applications of things like doing prototyping, creating concept modelings and functional prototypes in the past. But with the technology's advancement that we are seeing now in a few years of time, the technology has actually advanced into areas where you can do far beyond than prototyping, thanks to the availability of materials, the establishments of software in the market, like PTC or even like the Materialize. This has actually helped the industries, has moved forwards into going beyond prototyping. So we have seen nowadays is that for 3D printing is used in various different industries, such as like medical, automotive, aerospace. Take an example of aerospace is that some of the parts is actually producing out of 3D printers that's flying all around the world now in today's era. So you won't be surprised that if you next time when you're on board on a plane itself, some of the parts in front of you might be actually fabricated out from 3D printing itself. And moving forwards is that additive manufacturing in the future is that the technology will continue to be a mainstream technology, even replacing some of the key applications of how things will be made, and also will be a key technologies to supplement on your current traditional manufacturing itself. So Imagines itself is that in 3D printing is that this will continuously disrupt the entire supply chain in the world. And imagine if you have multiple different locations and have 3D printers set up as the same for different locations. What you could do is that you can just send over digital files into different areas, get it printed out from the printers, and then this will actually solve on your demand that is closer to your customers itself. So we'll be eventually heading into distributed manufacturing, and when we go into that area is that it will be a data-driven kind of era where data will play an important role in the entire additive manufacturing setup itself. So how do you ensure that the data are being sent correctly into different areas without being manipulated and print in a different location or different or extra quantities itself? All of this is about data. As you know, that data is the new oil in current modern era itself. So things like new technology like ChatGPT and kind of stuff is also driven by data. So that's the same about additive manufacturing. Let me give you an example. Is that in the eyewear industry, now we do see that there's a lot of people are wearing specs in the hall, and I guess that there is a challenge, when you wear specs, is that not every specs is actually fits into your face, right? I mean, it's a standard product, but each of us have a different structures or different shapes on your face. 3D printing has actually presented a very good opportunity for mass customizations of these applications itself. And eventually the industry has moved towards into digital eras where the consumers can just go into the shops and get your face scanned, and eventually the specs will be designed according to the shape of your face, and you can get comfortably wear it the whole days itself during your daily work. And this will continue to disrupt the eyewear industry. You may not see here now in Malaysia, but I believe in the future, so in the near future, you might be seeing this will be getting more common here in the countries or even in the regions itself. And now, if you move towards on this era itself, is that mass customizations and also printing it using a 3D printing technology. There is a lot of repetitive and also manual tasks that is being involved in these kind of processes itself. Thinking about it is that this is a standard, the shape is identical, but there's actually a lot of small little changes that need to make for according to the different shapes of your face itself. So things like this might be, the frame might be shorter, or some things that might be bigger and stuff. So this will actually consume a lot of time and also your efforts into putting on all this manual way of working on it. So when you work about manual processes itself, is that we do know that these manual processes are prone to errors. So if you are working daily on things about the same for many times, the prone to be errors that might be happening along the way. And in the eyewear industry is still okay, but if let's say that if you are working in things like medical industry, some of the errors that is happening might be very dangerous. Okay. The second is that is the inconsistency of delivered work. So operator one might be doing the perfect thing, but doesn't mean that the second operator will be doing the exact things itself. Given an example is that if let's say operator 2 does have an argument with his wife in the day before, and then this might affect the emotion, and then who knows that it gives the inconsistency of delivered work. This is happening not only in 3D printing, but of course in the entire manufacturing industry. That's why I think most of the companies wanted to go to automation, factory automation, to eliminate the emotional of human being there is. Okay. And the third is that if let's say we are focusing on the repetitive work itself, is that it doesn't really fully leveraging on the AM expertise that you have in your company. So all these people will just spending time on doing all these repetitive kind of work, the manual processes itself. So it doesn't maximize their knowledge they have in this technology itself. And the last one is that it is no time left for improvement. So if they are continuously spending time on all this repetitive work itself, is that there's no time left actually for improvement. And now we do see there's an opportunity in 3D printing where it can disrupt on a certain industry and also provide meaningful applications. And we also do see that there's challenges that's happening when we move towards on the mass customizations of using 3D printing itself. So is there a solution that is actually able to cater for that? Yes, automation does give the benefits and also valuable time back to the experts itself. So similarly, like what you have seen in the manufacturing line itself, is that automation does give benefits to the organization. In the next, I'll show you two examples of how automations can work in a different organization and how does that bring benefits into these two different organizations. The first is being Proto Labs. So Proto Labs is actually service providers that's dealing with a lot of 3D printing services around in the globe. And being the nature in service providers is that they need to deal with a lot of works and also batch productions itself coming in from different customers. So one of the particularly tedious work that they are facing is that on some of the cases related to spinal medical implants, is that there's a needs of labeling on all of the parts itself because of the nature of medical things. So you need to identify which of the parts actually belongs to which customers, as you can see from the image in the slides itself. So you can see that it's actually about the same identical parts, but actually each of the parts is actually a difference of it. So their engineers are spending a lot of times into labeling and all these kind of things. So it might seem very easy, but if you do this continuously, you are finding this is a very tedious job. Just for example, is that if you have experience working with Excel, is that Control-C, Control-V, copy paste and kind of thing is very easy. But imagine if I throw you 1,000 data and ask you to copy paste and each of the things into a specific area. So that might give some challenges for and also time consuming for the engineers. So we have actually worked together with I'm better off the sound. We have actually worked with Proto Labs for about 20 years, and then we are continuously working with them on to streamline their entire line itself with our solutions, offerings such as Magics or even like eStage itself. And this project itself is that we actually discussed with them and to automate their the labeling process into an automated way. So it is now from a very boring and tedious job to a very quick and motivating job for the engineers, so that their engineers can actually spend their time into other different works as to innovate more and also to provide more to the organizations. Okay, this is the first example. And the second example I would like to share with you guys is that is a work that we've done with Gears. So Gears is actually producing prosthetics by using 3D printing. While traditionally prosthetics are being made using traditional ways, a very tedious process. And now is that it is 3D printing does present a very good cases where it can help to digitize the entire workflow into 3D printing way, so that it actually eliminates the work, the previous tedious manual way that's working with prosthetics itself. So you can see that there's interest, or there's uptake of using 3D printing in prosthetic areas. But Gears does already embrace 3D printing, but being a human, I think we all are very lazy, and we wanted to actually do more of it and to automate most of the things if we can. And Gears is actually looking into solutions of how they can actually automate the design of prosthetics in their daily operations itself. So traditionally, they are doing things, following the design steps as the procedures of it to design the prosthetics itself. This is actually is a very long processes as well with the design of this prosthetic, and then they eventually work with us to actually develop automated design workflow on their prosthetic design process. And the outcome is that it is providing more time, to the engineers, so that they have more time into doing other different things itself. And now you might be wondering, after I talked about so many things itself, what Materialize is and what we actually does. So Materialize is a company that's based in Belgium, and we have started off our business since 1989. We have 30 plus over experience specifically in additive manufacturing, and we provide end-to-end solutions. We make use of our over 30 years of experience in 3D printing and fully digital fabrication method to create products that are unique, from scan to design to 3D printed devices. And we constantly also innovate to bring value by increasing efficiencies and creating the otherwise impossible and making more sustainable products. We also have a certified manufacturing. We created processes and products that's highly regulated, such as like healthcare and aerospace. And we also are an expert in also personalization and creating products that's unique to users, such as like hearing aids, eyewear, and also medical implants. This is actually thanks to the 4 different units that we have in Materialize, which is on the software side, where we are one of the leading software to manage and control the entire AM process, and 92% of the largest metal AM system manufacturers or 85% of automotive companies are users of our software. And we're also one of the Europe's largest and most complete factory for 3D printing, where we houses more than 175 industrial 3D printers with over 30 plus materials and also 90 plus finishes that's available. The third is our medical division, where we provide services that revolutionize the patient-specific treatments, and we have actually helped a lot of patients yearly. And last but not least is our mindware consultancy arm of business, which provide advisory services for business success with AM. So we want to make a difference through a difference in making. Okay, so we are specialized in end-to-end digital fabrication technique, and we often look at how things are done now, and also ask the big questions like how can we make a process more efficient. How do we get better result out of it, and how do we create the impossibles? Before I end my sessions, I would like to just put a summary. Is that if the audience here are looking into 3D printing and wanted to start on something and evaluate on something, please do not go alone of it, because you might get a lot of challenges. Instead of that, do find people that's around, the expertise that's around in the hall. You can look for us, Materialize, you can look for ArmRace, you can look for Philips, Machine Tools, PTC, or even ASTM itself, as to seek for their advice on how you should get on board on additive manufacturing itself. I believe with the combinations of our experience, we have more than 100 plus years of experience in the hall, so that we could definitely give you a lot of advices and preventing you go to the wrong way, so that you need to spend more time in exploring on this technology. So with that, I'll just end my short presentations. So yeah, thank you very much. Any questions, you can just feel free to reach out to me.
Thank you very much, Manchun. Finally, the last presentation of the day will invite Mr. Anush Budiraja, Vice President of Philips Additive. Thank you very much.
Thanks. Thank you. So that's the last presentation of the day before we end our day with tea and coffee. So, hi, good afternoon, everyone. So I'm going to take you through
few of the customers who have adopted this technology as using it for their production parts and their prototypings as well across different industries and globally as well. So few of the challenges which I think Richard has also covered mostly. It's about the current days manufacturing trends and the challenges. As we all know that post-pandemic supply chain has been a big challenge all around the industries, where either there are companies waiting for their parts to reach them, or there are companies having plenty of inventory standing there and there is no customers for that as well. So it's a big challenge across manufacturing industries nowadays. Rising cost of the raw materials, again some borders were really closed, and metal prices, so there are a lot of raw materials, the pricing have gone more than 57% higher as well, which is kind of delaying some of the product development and time to the market of the new product launches. Apart from all these, manufacturing industry is definitely facing a challenge on the skill and the skilled labor, where we need people who could be trained machinists or could be trained in the additive manufacturing technology as well, all the new disruptive technologies which are coming up and industry is adopting. There's very, it's most of a skill dependent, and definitely the sustainability initiatives about the ESG, where industries are looking for reducing their carbon footprints all around the world. So now these are the challenges of the modern day of manufacturing, and we know that there is a solution for that, which is already there, is about digital manufacturing, where we print the part digitally. When we know that the volumes are low, the batch production is going to help us by producing these parts digitally and printing or manufacturing the part at the point of need, rather than flying those parts around the globe whenever it is indeed required, or rather than keeping a physical inventory in huge numbers. So can we look into some solution which is digital manufacturing through adopting the additive manufacturing technologies all around the different organizations or at the different locations? I'll show you some of the examples how industry has adopted it. So coming from the Markforged, obviously there is a solution which is a cloud-based architecture, which is helping the industry to move from physical inventory to the digital inventory, and it is helping the industries to make the distributed manufacturing to the digital manufacturing as well, where we can control all different printers all around different plants through one location. We can control the part which we are printing, we can control the design as well. The benefits are, in no time at that particular location the part is being printed directly. So in few hours, rather than getting a part flowing around from the different parts of the world, so we can actually print the part at the site itself. So I'll show you one of the examples from a global company, Vestas, which is a global leader for the wind energy. So we all know that wind energy equipments are really expensive and kind of complex as well. No company would like to have a downtime in them. So now there are some tools, there are some parts which can be manufactured directly at the point of location. So Vestas, being a global company, earlier they used to send millions of parts all around different plant locations, where the team used to have these parts, or they were keeping a lot of inventory of these parts. Now there are some of the parts which they have started printing it at the point of need at the global different locations. So there is a short video about how they have adopted this technology, which is helping them to reduce their carbon footprint, which is helping them to control their design and have the single design capabilities being driven globally over the cloud. So short video from Vestas. Can we have the volume, please? Oh, it's in mute. Sorry.
For reliable energy. As a renewables company, wind is plentiful. It's just waiting to be captured and harnessed.
Wind is our fuel. We see it as a sustainable source for reliable energy.
As a renewables company, Vestas has a high stake when it comes to sustainability and carbon footprint reduction.
Vestas is the world's largest wind turbine manufacturer globally.
Our mission is to drive the world towards renewable energy. We have design elements that are kind of scattered around the globe. We have a centralized team in India, people in Denmark and the United Kingdom, here in the US. We could be having a part shipped from Germany to the United States. In terms of sustainability, that is a substantial amount of fuel and time and resources.
The solution to that is direct digital manufacturing, or as we call it, DDM. We've equipped all of our blade manufacturing facilities with Markforged printers to have a rapid response to an ever-changing product.
We use it for instantaneous validation of design concepts. We use it for collaboration. We use it to free our manufacturing processes from the constraints of outside suppliers. With DDM, we don't compromise. What we've done to kind of flip the script is we're no longer just providing the instructions, we're providing the physical article in near real time. I mean, it's the closest thing to teleportation I think you can get.
So this is how Vestas has been using it. The name tells itself is DDM, Direct Digital Manufacturing. So rather than keeping the physical inventory there or sending the parts to different parts of the world, they're just printing these parts directly at the point of need. Another example is from one of a global company, Vedanta, who's into metal and mining. So they have started they have actually set up an innovation lab within the plant itself. It's a huge plant in the remotest area of India where they have set up an innovation lab where in last 2 years after the implementation, there is a mandate that if any spare part is failed or it is required, which is not there in the plant, that innovation lab with the 3D printer has a first right to refuse, whether they want to print it or they want to procure it from the OEM or from the spare part market. Because if they can produce it, if they can print it there itself, then it will be in few hours rather than spending some time. Like this is one of the part which is kind of a fluid coupling for forklift assembly. So earlier it used to take 90 days to get those kind of parts from the OEM or from different countries. And now they can print it in 4 hours. And they have somewhere around 150 plus forklifts in one plant itself which are moving around. Now look at the kind of failure time which they would have seen or the kind of physical inventory which they would have kept for that, and now within 4 hours it's all up and running and they can directly use a 3D printed part. Similar way, one of the autopath grinding machine, again it used to take around 45 days to get those parts, and now they have started printing it in a couple of hours within the plant itself. So this is the kind of advantage of using these technologies, starting to use it for their different kind of needs. 3D printing, additive manufacturing, different names, it's already been there from last 30 years now, but now with the introduction of all these kind of new materials which are being launched by Markforged as well with higher strength also, which is helping them to adopt this technology for end use part, production parts or spare parts as well. Another example is from one of the institute, National Institute of Fashion Technology. They have kind of looked into setting up a center of excellence to provide support to the industry who is into fashion and garment manufacturing. Being in university, they want to help the industry to drive this 3D printing or AM adoption there. So they actually have launched a website which is same day spare part. Now that fashion technology or garment manufacturing industry, whosoever needs some kind of a specified custom tool or a spare part, they can directly order it within the same day to this website. And they are all printing it on the Markforged printers there. One of our customers, Mylene, they started around 7 years ago. It's a young company in India which is into drone. Their first manufacturing machine was a 3D printer 7 years ago. Now they have 20 of these printers and they are printing those parts directly for producing composite parts, metal parts as well. If you look into the screen, there are two parts. It used to be a coupling which was in aluminum weighing around 40 grams. Now they replaced it with a carbon fiber based 3D printed part which is 18 grams. Now if we look into the overall drone concept, so reducing the weight of the drone by using this technology, almost 50% of the weight in one coupling itself is helping them to design a better drone with higher payload capacity as well. So this is where the technology is taking them up. Another interesting example is from Indian Navy, which is a Ministry of Defense of India. So they are the first one in India who have conceptualized and thought of having a metal printer on a ship in a container. So the trials have already been done. Next week this ship is going to sail and they are going to print a part while sailing in the sea. This is one of the greatest initiative taken by Ministry of Defense, where they are saying that the challenge to get these parts while sailing sometimes creates a huge loss for the different kind of ship. Once this is done and successful, they would like to have one printer installed in a lot of ships. Every ship should have a printer rather than having multiple containers of the spare parts. They can't send somebody back on the port while sailing to get the parts done. So they have to keep the physical inventory, or the other way is they have to keep the printer. Now this is where the industry and the technology is going to help the industry. There are a few of the applications in the aerospace, as we have already seen that there are a lot of applications where the industry is looking into that. It's like kind of a more of aerospace industry has moving to the composite, which is kind of after using composite, they are 50% by weight. It's like composite, 80% by volume as well. This technology is helping this industry to move these lightweight concepts, to move this low batch production by using 3D printed parts. It's all possible because of the materials which are being introduced, which are aerospace friendly, which are flight worthy. Materials like Onyx FR, which is Onyx flame retardant aerospace, with the whole traceability, be it in carbon fiber as well. And these are ready to be used and adopted by the aerospace industries. And this is not only about using these parts within the aircraft or the cabin itself. There are a lot of parts which can be used as a tool as well, or we can produce the tools by using AM. If you look into this slide, there's a tool which is being used for this forming, which is being 3D printed as a forming tool. Rather than using a metal block and then go through the CNC processing, obviously this is going to be much lesser in time, which can directly be 3D printed, because we all understand that aerospace industry is kind of a low volume batch productions. We may need maybe 50, 20 or 100 pieces of this sheet metal tool. So why to look into the subtractive process for these kind of application where AM can directly be a beneficiary out of the overall process. Similar way, some of the inspection toolings and obviously the interior components which are already being started using. One of the company like Cabin Management Solutions, they have already started using the 3D printed part in the cabin itself. This is all possible because of all these new materials. If you look into Markforged solution in the portfolio, there are materials which are FR based, which are ESD based, which are aerospace grade. So all these materials are available to be used directly as a production part. And this is all possible because all the industry who is embracing this technology with the defined materials, with their kind of materials which are available now in this technology, is helping them to reduce their product development time, helping them to improve their plant downtime as well. Just like Indian Navy, who have started using it for their spare part production, which is helping them to reduce the inventory being carried on a ship while sailing. Now if they know that these are the 50 parts which they can print whenever it is required, they will reduce their inventory of those 50 parts on the ship, because there is a printer which will help them to print it on the go. So before I end my presentation, just a few slides about Philips Corporation. So we are a 60-year-old global company based in US and India, Sri Lanka, Bangladesh, Africa, and in Malaysia we have signed up and partnered with ArmRace now. So we are partnered with them in driving the 3D printing AM and subtractive adoption in the country. We have different technologies in subtractive and additive, starting from milling, turning, grinding, and additive manufacturing, different globally located in the different locations. And one of the initiative which we have started very recently, in a couple of years ago, is around the education, where we see that all these technologies are going to help the industry, but then the industry is also looking forward for the skilled manpower. There's a huge gap of the skilled manpower who is ready to adopt this technology, who is ready to implement this technology in the industry. Sometimes industry has a fear that if I spend millions of dollars on this new technology, do I have the right people to use this technology? Will my ROI will be there if there is still skilled people who are not there? I can't ask my person who is using one of the technology from last 30 years, he won't be able to give me that kind of output. So this is where we are helping and aligning with industry as well as universities and the schools, where we are helping them to set up center of excellence to bridge the gap of the required skill set in the market, required skill set for industry 4.0, providing all the certification courses, train the trainer program. So this is all around for additive as well as for subtractive also. There is a huge gap and huge shortage of skilled manpower, which prompted us to start this kind of initiative, having spent 60 years in the industry in subtractive and additive. So we thought this is the right way of connecting academia with the industry and fulfilling the needs of the industry by providing the right technology and the right skill set and the skilled manpower also. Yes, with this I'll end my presentation. Thank you.
Thank you very much, Mr. Anush. Now, we have completed our set of presentations from all the panel speakers. Now let's invite all the panel speakers up on stage for a quick round of panel discussion. And now this is your time, that all the questions that you have, it is time to ask our dear panel speakers if you have them.
Okay, so we've got a small group out here. In fact, it melted down a little bit, I think, throughout the discussion. But I think let's make this interactive, right? So questions from the audience, really, so that they can give you some insight to some of the stuff that you might be interested in. Can I invite a question? Yeah.
No, I don't have any
Okay, you
question.
don't have to adjusting yourself in the seat there.
Okay, I have.
Yes, please. Yes.
On the software, when you show, during the presentation for the software with AI design. So how, after we reach, let's say I have the initial design, how flexibly the AI can change my design and what the limitation I set to change the design?
Okay, so the process of using that capability, so at this point is we put in the parameter and they come up with the model for me. So I can set parameter, material, what is the manufacturing process, so it can be a custom part, it can be a 3D printing part, and the system will generate for me. And once it's generated, within the CAD software, if you want to make changes, we got flexible modeling capability inside, you can just change accordingly. Or maybe certain things you want to make it standard, you can copy standard features on top of it. So it doesn't optimize the existing design, but it can create a design from your parameter. Yeah.
Okay. So let's say I'm using 3D printing.
Okay.
So the design will be optimized to, let's say, remove support or how?
Oh, it does. So you can select that. Yeah. So because like I said, you can select based on the manufacturing process. So what type of 3D printing is it for plastic? Is it for metal? And we also have the collaboration with the different printers. So depending on what type support structure, that will also take into consideration.
So for example, if I am printing using metal,
Yeah.
so let's say if I have the metal X,
Yeah.
is it included in the software?
Yes, it is.
Okay.
So basically, what we do is we use materialized underlying technology because they have that capability. So that enable us to connect to the Metal X or the metal 3D printer.
For example, compare Metal X with desktop metal. Desktop metal is based on powder,
Yeah.
and Metal X is based on the filament.
Yeah.
So both printer.
Yes. So you basically you can select which one, then they will create that model for you.
The final question.
Yeah. Sure.
For the software, can I have a trial online, or can I download a trial version to check or test my design?
I can facilitate that trial if you require. So later I'll pass you my name card, then you can just write to me. Or we can also facilitate through ArmRace, then we can let you try out, no problem.
Okay, thank you.
Yeah.
So on the software part, Markforged has also launched the simulation part. If you have already used it, and it's okay. We are adding up the Metal X simulation also very soon into that. Just to add a little.
Today they launched the
Yeah.
stainless steel.
Yes, that's what we are saying. So we are adding it. And digital desktop metal also is kind of, they have wire based and powder both. The similar way Markforged has the binder jet also. So all these modules are going to be added up, the basic ones, but for rest definitely we'll be using PTC and the materialize.
So can I ask which industry you're from?
I'm from prosthetics and orthotic medical.
Okay, prosthetics. Sorry. Okay, excellent. Any other questions from the audience? Yes, there. Thank you.
Uh, so I'm from academia, and currently I'm working on a new approach for 3D printing and additive manufacturing of a special metallic alloy. This metallic alloy is some kind of very thermal sensitive. So if it is subjected to thermal energy for a while, then the properties can be changed. So currently I'm developing this approach. Maybe I'm halfway, but I'm still lacking of the facilities of 3D printing. So I'm just trying to do it manually. So I'm currently looking for the some collaboration or something like this cooperation between a company to implement my idea. So I'm looking for this opportunity. Is there any chances for this?
Okay, so I've got two questions for you from ArmRace. Oh, hang on, you went home and Number one, what is the application for the metal that you are looking to introduce into this new manufacturing process?
Okay, this alloy can be used for biomedical applications like implants and so on, dental, bone implants, prosthetics, these kind of things, and can be used for the high wear applications for severe tribological properties and so on. So this alloy can be applied in these two applications mainly. Yeah. There is
What's the benefit of this alloy over whatever alloy we're using right now for prosthetics, for example?
From my findings, the first one is its superior tribological properties compared to titanium, to stainless steel, to what we have currently. Secondly, the high corrosion resistance, and third, it has very high mechanical properties.
Okay.
So this kind of 3 points brings this alloy becoming popular, not popular, superior to what we have currently in terms of metallic alloys.
Okay. And which university are you from again?
University Malaya.
Okay, so you're from UM. All right. Maybe I get the standards guy to comment a little bit just on the problem statement that is put forward.
Yeah, at this moment, for special materials, special alloy systems, so for standards, we develop material specifications for materials that are standard. For example, 316L is a very common material. For that, we can develop a material specification for 316L for AM. So a material specification for 3D printed 316L stainless steel. The thing about standard is that we require consensus. So when you bring your alloy to become a material specification standard, there must be consensus. That means people must agree to that alloy. The thing that we are facing since 2009 is that a lot of OEMs come in with their own material, wanting to develop the material specification standard. However, when you come in, your competitors are also coming in. So your competitors are in the same working group who will go against your claim and say that no, they do not have consensus on your alloy. But if you come in with a standard grade, say titanium grade 23, titanium grade 5, all of them will more or less agree because it's a standard specification alloy that can be used and adopted easily. So for that reason, for a proprietary alloy that you have developed, to make it to become a standard material specification, it will not be able to be published because no one will agree to that. Yeah, that is the challenge that we see.
I agree because I understand this point, but this alloy I didn't develop myself. This is a continuous research from others, and I'm trying just right now to develop a new way to additively manufacture this alloy. because there is some iterations and some trials, but it is very limited. The size is very limited, still very small. So I'm trying to get the bigger size. So that's my passion right now.
Okay, then I understand where you're coming from.
Sorry for interruption. And it is still in the research stage. It's not getting to be commercialized or industrialized.
Okay, so the thing about standards development is that besides consensus, there must be adoption. That means there must be enough people to come in and who say that they're working on the same alloy, on the same process. So every working group, we require at least 7 to 14 people to come in to say that, yeah, we are working on this and to develop that standard. And once that is, the draft is done, it's sent to the 1,000 members who will come in to provide comments. So unless the 1,000 people also have worked on that alloy, then the comments are going to be positive. So it will go through the ballot. The thing about this new alloy or it's an established alloy in the commercial world, that means commercially available alloy, but it is going to be used in AM for the first time. This is going to face a roadblock because not many people are using it in AM. So for that reason, we may not be able to arrive at consensus, and the response is not going to be that positive. Yeah. So even for AM at this moment, for metal alloy, okay, there are only 6 material specification standards, because these are very common and very standard alloys that people are using. The 7th one is coming, which is maraging steel, and even maraging steel is very common as well, but also common in AM, but less people are using it. So only recently that they're going to develop that material specification. So for a very new novel alloy like the one that you mentioned to be used in AM, that's novel. That one will take some time also.
So, as far as the collaboration is concerned, I wanted him to give the framework of what would happen when a collaborator was going to ask you a question of whether or not your work can be useful to the collaborator. And I think those questions would all come up, right? So, not to say that you can't. I think what you have to do is you have to consider all of these things, and then in your roadmap for this material, at which point will you be answering these questions, right? And then look at a viable collaborator at the level of maturity of the technology that you have now, right? And then only you can start saying, okay, all these guys strike off the list, they're not going to talk to me because of all these things, but maybe there'll be a few that say, because of the specific application, I don't mind doing a 5-10 year research program with you if it can solve this problem, right? So yeah, fortunately with UM, I've had a few engagements where we've had this challenge where you guys are doing fundamental research, but because your engagement with the industry is not so clear, right? When you roadmap these things, it's difficult for industry player to come and talk to you and say, well, is this useful for me or not? Should I put money? Should I put time and effort into it, right? Yeah, so hopefully is that useful? Yeah.
Yeah,
Okay.
Najib, I think you are spot on. So there is a roadmap on AM standards, and they identified 91 topics, and they grouped them into high priority, medium, and low. So not to say that yours will not work, but most likely yours will belong to the low priority standards gap, where the community globally are always looking to address the higher and medium priority gaps.
Okay, I think I'm too tempted because Cik Akmal is sitting right behind you there. A very experienced CEO of many companies. Cik Akmal, could you either share some experience or ask us a question?
Sure. Assalamualaikum and very good afternoon, everyone. I was involved with 3D metal printing a while back. That was when I was involved in aerospace. Then after a while I left aerospace. I'm doing something else. First thing first, interesting question. The issue then, I'm talking about 6-7 years ago, the material supply, has it changed? So has it changed that much? I mean, how many suppliers are there in the market?
For powder, metal powder.
Yeah.
Right now, I think about 100 over powder manufacturers, metal powder manufacturers, about 120 plus.
What about within our region?
Our region.
Yeah.
Our region, we have in Singapore there is Atomizer, Taiwan, there is a few. India, there are a few as well. Malaysia, there's one. Japan, Korea, they have as well. Yeah.
So I think number is much more compared to before, because there was a big challenge before, because if you buy this particular machine, the supply only from this particular supplier. So because of limited number of suppliers, the cost of production, and then you were saying earlier during your presentation that as far as aerospace is concerned, they always want a new batch, and of course you have to have a special room kind of thing. So of course this is one of the technology that I believe will conquer the future. My only concern then was this material supply. If because if you ask me if somebody have to involve in development of new technology, there would be to get more suppliers for this for the material. Otherwise, I mean you can say you can do mass production kind of thing, and of course we are moving from prototype and small scale production into high scale production. But if that is not addressed, then it's quite difficult for us to challenge the normal CNC kind of production. Because in my recent experience, I was attached to a manufacturing company for about 6 months. I'm a consultant now. Certain thing has to order directly from United States, and then aerospace, you have to follow the lead time cycle. If you miss that, and you miss the production or the delivery or the supply, does affect the overall production of part which we are responsible for local and international players. So to me, that is still a key. What you're doing is good, but I believe going toward commonize the production of material is probably something critical right now. Then you can translate it or transform the additive manufacturing or 3D metal printing. Not to say probably not at par as CNC production, but maybe not far from that. Thank you very much.
Can I translate what you just said to 2 questions for the panel? Actually, first thing, it's not a question that you said. Jack Ma was also the CEO for one of the largest logistics company in the country after he was the CEO of one of the biggest composites aerospace manufacturing companies in the country, right? In logistics, we saw in the factory logistics of Vedanta just now, right? Spare parts. Are there any other fantastic examples of how in logistics companies 3D printing is playing a part in spare parts production, or maybe even on-site production?
Another global company who is using this technology to serve their customer on the spare parts is Brut, WUERTS. They are one of the largest global logistics spare parts company. They have started using, they are the partner with Markforged as well, so they are selling the technology as well as they are printing those parts across the world and then supplying those parts as well. They are purely logistic company actually. So they are not operation owner operators.
So he used to deal with prime movers, right? Trucks, lorries, hundreds of them, right? Are there parts? What kind of parts on such prime movers could today be 3D printed as spare parts? Could you do the drivetrain in 3D printing?
No, not the drivetrain. As of now, I would say there are parts like I've seen Caterpillar using the 3D printed part. They have started JCB, Caterpillar. They have started using it from the implement side, not on the engine side as of now. Implement and all the accessories also. So there are a lot of applications which are easy to use, easy to adopt as of now, and as all the new materials and the affordability of printing those parts at a little bit higher side in terms of volume, I'm sure industry is going to adopt that. I would say first step is already cleared. They have that confidence of using this technology in the end use part. The major roadblock was, can we use it as an end use part in the industry or not?
And cheaper.
Yeah.
So that would be a useful thing if in a logistics company you think, having run a large logistics company.
Yeah, sure. But then again, at the end of this, that's why I keep saying about the mass production or availability of the material, because the more material available in the market, easily, I mean, we have one in Malaysia, so this one will bully everybody. This guy will bully everybody. Because I get it from Taiwan or from Singapore, probably it's the cost element, import element, so it'll be more expensive. So if you have, say, 10 supply in Malaysia, so tendency for the application to other than aerospace or cheaper component is probably there, market probably there.
Okay. So the second question, I'm not sure who can answer this one. Maybe you can answer it twice, two at the same time. Was he was talking about the logistics timeline, right? Which today, I order material 6 months lead time for my aluminium block to come from wherever it is.
Yeah.
And then because of that, I've got to inventory probably 6 months worth in advance. So I've got cash flow up to 12 months tied up in my factory, right? How does 3D printing then shorten this problem statement, or what are the main elements of 3D printing that will resolve certain parts of this problem statement?
So there's no solution. It's the same inherent problem. The 3D printing could be worse because you store the block to produce powder. You need the block of material, right? So at the factory, you want to produce powder, you need to order the same block of material that you have 6 months of lead time. Then you have another 6 months of lead time to produce the powder. So they have to stock material. But I want to address what's the important thing about the cost of powder. I was speaking to this oil maritime company. You probably know that company, but they at their peak they produce 13 oil rigs per year. One oil rig is $500 million at their peak. Okay, at sunrise they produce 13 oil rigs per year. They purchase steel at $1,000 per ton. That is $1 per kilogram. When I first started in metal 3D printing, 1 kilogram of stainless steel is $120. This is 120 times of that they are purchasing. Today it has went down a lot, about $30, but still 30 times of what they are paying right now. In fact, they are paying less than $1,000 per ton now. So with that comparison, they are thinking that there's no way for them to adopt because the amount of material that they use, you cannot replace with 3D printing. So if you look at 3D printing, it's a very nice and unique technology. But when you produce component parts, right, you are producing at a component level. And then if you go at mass production, I used to work for a US service provider. I tell you, you go to any industry mass production, meaning to say 1,000 and above, not even mass, right, just 1,000 pieces and above. Cutthroat, the margin they tell you 3-5%, maximum 10%. There's no way to make money at all if you're using 3D printing to address this industry. So what you need to do here is you utilize 3D printing for application that traditional industry cannot produce for you. Exactly. So you include functional element into the printed part, which is design. Yeah. Then you can justify. Why the medical and aerospace can? Because the aerospace always high value parts. For hip implant, for example, you print one hip implant, right? That's not a component, that's a product. For product, your margin 40, 50%, 100% people buy because it's customized, highly individual. So that kind of industry, yes. So we got to really find a good application and navigate around to utilize the AM technology. So I think at this moment for automotive industry, probably you cannot utilize 3D printing yet. But indirectly you can. I think you know about the conformal cooling and injection molding. Basically you can print parts with inserts with conformal cooling channels. So that one, yes, they are already using. In fact, since 2003 they have been using it already. Yeah, but if you're talking about direct components to be used as end-use part, that one we really need to find a unique application for it. Because otherwise, if you always go back to cost, people will say that I can use my traditional to produce at half the price. Why would I go to you?
I think that's the reason why we're talking about aerospace industry. I have one more question. I think this is for the sake of discussion. So far, unless it is dedicated for 3D metal printing, normally they design using the normal traditional CNC method. And then to translate, for example, if a parts design say in US, they produce in US couple of unit parts and then send it to, for example, say Malaysia. It takes quite a lot of time for Malaysia, even though the design is ready, for it to be able to produce as per the required design or standard. in this particular case, how long do you think, I'm not sure whether it's been done before, to convert from, say, typical CNC, in case, say it's a unique part, it's not a typical part. How long do you think you need the 3D metal printing required from the design or the drawing into, say, FAR, for example?
Okay, ballpark.
Yeah.
To print a 7.5 kilogram of component on steel, it takes about 7.5 days. Ballpark. So to print and produce a component that is 7.5 kilogram, it takes 7.5 days.
I think that the concern is more on from the design drawing into
A 3D printable design.
printable design.
Okay, I'm telling you, this is in Singapore. We face exactly the same thing as I think in Malaysia. We have design capabilities. Malaysia has design capabilities, but the problem today is we are not the design owners. Boeing, Airbus, they are the design owners.
Correct.
Right? When you place an existing design, if you want to change the existing design and put into their system, they will ask you, "Are you sure your design will work?" They will not accept your design because you do not own the design. So in Singapore, we are exactly the same problem. So what happens is eventually we will have to wait for them to give the design, then they can produce or something. So design capability is not difficult to acquire. Yeah, so they can do it themselves. So eventually this will not flow to subcontractors like us. Yeah, I think this is the key issue that we have. But eventually, if you look at ST Engineering, they are the design owners of a lot of designs for defense parts. Yeah, then they can do a lot of defense design for AM. Quite straightforward for them. But for aerospace components, still the big boys. Yeah.
Yeah, thank you.
Thank you. Any other questions? Yes, right. Got another question in front here.
For Mark Force, now, now the limitation, I think, for the printer is the material is locked. We cannot use a third-party material. So, is it going to change in the future? No.
As of now, I don't see it to be changing because the customers are demanding the accuracies over there. So till the time we have the control on the material quality, we won't be able to control the accuracies as well. As of now, I don't see it to be changing. There are few materials which may open up soon, could be PLA kind of a material which is the standard. But when we talk about the industrial grade materials, then it is different as of now.
For the FX20, is it going to improve to print peak? Because now it's not printing.
Yeah, as of now, it's not.
Excellent. Any questions? We have another 10 minutes before we go to the live demonstrations outside. Any other questions from the audience? Well, I will ask 2 questions otherwise. But we want to give you a chance to. Yes, there.
Hi, I'm David here. I'm actually a jewelry manufacturer. So we have been using 3D printing technologies for quite some time. And I've been observing this laser sintering technology for, I think, 10 years back when the EOS started to bring out the first 3D printings in precious metal. And it doesn't seem to go very aggressively until today. We doesn't see a lot of people using the direct printings for the precious item like jewelry. So I just want to know, is there any reason why it's not been using aggressively in the industry? And is it because of the powder issues, or is it because of the gold loss that in the productions and this and that? Just curious.
Can you realize you have experience with this?
Yep. In fact, I think we have a lot of customers in jewellery as well across in the region, particularly in India and also in Thailand. And of course, we do see some of the renowned jewelers are actually adopting metal 3D printing, I'll say. But in fact, is that like what you say is that they are not using it as a way of mass production at this moment. I think simply because it's the surfaces finishes as out from the printer is not as comparable to the traditional manufacturing as of now, of course. And the second one is which I think is the details of the printings of the printers. But of course, you know, with the technology advancement, like I've seen apart from coming in from digital metal, it's very fine details which I believe that it will eventually change the landscape of you know, in this industry itself, where people can start to look into printing in jewelry, for example.
So is that limitation the nozzle, the design software, or the material?
I guess it's because of the nature of the technologies itself, is that because we are using a sintered kind of
process itself.
Yeah.
Okay.
Beyond certain acquisitions with jewelry market.
I see. Okay. But this new technology seems to be able to produce that.
I think Mr. Anush maybe give
The binder jet there.
Binder jet.
Binder jet, which is like PX100, the digital metal company which Mark IV just acquired.
That's a binder jet technology. So what he has been using, it's DMLS, metal laser sinter.
Okay.
So that is the limitation.
Okay. Does that give you some visibility? Yeah. So maybe soon.
Yeah.
Is that cheap to use? The
No,
metal
Jewelry can't be cheap, right?
It's all perceived, right? Only business that makes sense with 3D printing today, if we can do it. Any last questions? Any last questions from anyone? Oh, yes, okay.
When you presented the socket design,
Yep.
so the socket design, we have different standard and different type of sockets depending on the amputation, and it depends. Okay, you show us transtibia amputation, and then okay, the software will give the ability to choose what type of design we need, because the pressure point will change based on the clinic suggestion. The doctor will suggest some, the surgeon will give us some input as well. So how is the software usually will? Because for now, in my company we use Rodin Neo, but still a lot of manual work. So we need an experienced person to do the design. But is the software going to help to speed up the process? Let's say I select what is the standard, I select the pressure point, and it will be done.
Okay, the example that I showed just now is one of the projects that we work with Aegis, and of course they give us the inputs of, you know, what sort of design is this to cater for different set of scenarios, and then based on the you know, inputs from the customers, and then we help to automate the entire design process. So I have to make a clarification here, is that our software doesn't really go into, you know, details of designing the prosthetics. We can design it, but it's just that the case study that I showed is that how we actually helps automate on a certain design. Or maybe give you another example, is that on orthotics, we have actually worked with orthotics companies to, or in fact we are also the orthotics manufacturers using 3D printing. And of course is that we are leveraging on software capabilities so that you know, the podiatrists or the therapists can actually from the software, based on the scanning profiles that you get from the patients, and to select what kind of treatments that's actually needed. So from that, the inputs will be then generated into our backend system, and some automation will be running. And based on what is actually input from the podiatrist and itself, is that it will generate the sort of orthotics that is suitable for the customers, and then it will send it to the printers for printing itself.
Tim, any last words on design? Okay, I'm a mechanical engineer, so I may not have that domain knowledge, but I think currently in that area, I don't think it's so automated because every of them is unique, so we still need the human input. In the future, maybe when AI become more mature, they may collect that data, but I think at this point, that's not available. That's in my
limited observation. Yeah.
I was saying that maybe, in the case that we need to, we can minimize the interval of people's into the design processes itself. The completely automated design, I think we are still way to go from that.
Excellent. So, Cheng, our next event's outside, right? Yeah.
Hi. So that concludes all the presentation and the panel discussion. So thank you everyone, thank you to all the panel speakers for the wonderful discussions, and thank you for the very good questions. Now, we will proceed outside for high tea and for some food, and you can get to see the samples, the printers, and then we'll give you a quick run through of what Markforged printers are about. We have the Mark II printer outside, and we also have the X7 outside. So